Hello and welcome to day three, episode three, whatever you want, the number three of this journey. I've really avoided saying the word journey, of this this development, this path we're taking to create a password managing app. Well done for showing up again. Well done for continuing with this and sticking with it. It's going to be something that we add to little and often and build up little by little. And we're going to commit ourselves to trying to not rush things, not try and solve everything at once, but just focus on being able to break things down and systematically work through them. So we're going to start off by revisiting our to-do list. Okay, and last time we oh no, what's going on? Okay, just a little. I'm okay. Okay, just decided to refresh there. We had this little version that we've been incrementing, so I'm going to jump down to main and I'm just going to make 0.3, version 0.3. Fantastic. Okay, so we've incremented the version, fantastic. And last time we made a little logon system. So if I just run this, let's just remind myself, we can log in, enter our username Bob and our super secure password, password1, password1, and huzzah, we log into the account and then we can exit and lovely. Okay, fantastic. So this is working. However, in our code, in our authentication file, so in authentication.py, we have this where we just say if username equals Bob and password equals password1. This isn't very good. And so we're going to fix this today. And that's what I mean when I say improve Logon System to be more secure. We are going to make this much more secure. Now, I've put a little bit of code here that I managed to get just to remind myself of how we're going to do this. This one line is going to do some pretty fancy stuff, but what I'm going to do is I'm going to break it down for you and show you kind of what's happening here, so that we can understand how we're going to be storing Bob and password1 in a file. That means someone else won't be able to just come in and see it. Okay. Now, you might not have noticed before, but repl.it has this thing called shell next to the console. I'm going to click on that, and this will take us into a shell. And in the shell, we can do loads of stuff, but I'm just going to simply say Python 3. And what this will do is it will open a Python interpreter where I can just literally type in lines of Python, and it will, what will it do? It will run them. That's what it will do. So I'm going to say name equals, and then I'm going to put in the string Bob. Okay. And now I can say name and it's got the value of Bob. Fantastic. So we can just type code in here and it will work. Now I could say name dot, let's say, is it title? Can we do title case? And there you go. See, it's capitalized the B. If I do name, get Bob. Okay. So if I import a library called hashlib, so hash library, we are going to use the hash library in order to hash our username and our password. Now, what's a hash? A hash is a way of taking any string, so like Bob, for instance, or username 1256 blah blah, and converting it into a kind of random, fairly random sequence of characters at a set length. So no matter what the length of your input is, you'll always get the same length output. And so this is a really strong way of encrypting something. Now, the thing to know about hashing is that when you hash a value, there's nothing you can do to the result of it to turn it back into the value, right? Once I hash Bob and get the hash, I can never take that hash and run it through something else to get Bob back out. It's a bit like if you were to put your dinner into a blender, blend your dinner up. Okay, you wouldn't be able to then return it to what your dinner was before you like whizzed it up in the blender. And that's kind of what a hash is doing. So let's see it in action, and it should start to make sense. So you can see here, we need to encode our string first of all. So I'm going to say name equals name.encode. Now I'm going to say name, and you can see it's got a B before Bob now. That's because encode has changed it into a binary representation of Bob rather than or a byte representation rather than a Unicode representation, I think. I did skim read the reason for that yesterday, and that's kind of coming through now, you can tell. But that's okay. So what we're going to do now is we're going to say hashlib. We're going to call this raw hash, I guess, for lack of a better word, equals hashlib dot SHA. So that stands for secure hashing algorithm. And there are a fair few secure hashing algorithms, but we're going to use secure hashing algorithm 256. And we're going to pop in our name that we have encoded just now. Okay, so we encoded. Oh, no, come back. There we go. We've encoded our name and into bytes, and now we can hash that. So I'm going to do that. And now if we look at the value of raw hash, you can see here we have a SHA-256 hash object, and then I think that's the memory location where it's stored. So in order for us to see this, we then have to run this hex digest function. So we're going to say our actual hash is equal to our raw hash dot hex digest. I hope you're still with me. I hope this is making sense. So now what we've got is a hash of a fixed length. So if I say hash, this is what I've got. This is the result of hash. We've turned Bob into this, okay? This big, long hexadecimal number. This is hexadecimal. If you don't know what hexadecimal is, we're not going through it now. We're not going through it now. But the short answer is, imagine you numbers, but you go up to F rather than 9. That was a terrible explanation, but yeah, you'll see some letters in here. You'll see some numbers. We're working in hexadecimal here, and we have our hash of Bob. Now this will be the same length if we'd put in password 1, or if we'd put in anti-disestablishmentarianism, or if we put in anything, we'd get this same length hash out. And it is impossible to take that hash and run it backwards through something to find out what it originally was. The only way that we can find out what this was originally is by trying every word and hashing every word until we get a hash out that matches this hash. And that is the beauty of hashing, right? So in your dinner blending example earlier, when we blend up your dinner, when you blend up your dinner in secret and you show it to me and you're like, guess what this was? And I'm like, I don't know. But then I just go and blend all the different meals until I blend a meal that looks like the meal you've blended. And I say, oh, I think it was spaghetti bolognese because these look very similar. Or these look exactly the same. And that's kind of what hashing is. We're kind of blending it up. We're getting this output, and we can only find out what it was by doing it and comparing it. So that's how we're going to be storing our username and our password. So I've got my hash for Bob here. So let's copy that. Obviously, oh, hello, keyboard interrupt. Let's copy that. Obviously, you don't have to use Bob. You can use some other kind of name, username. You could use any username you like, and you can hash it using this rather easily. We are probably going to make should we make a function? Yeah, let's make a function to do that for us, actually. That would be a good use of our time. So let's say import hashlib. So I'm working in the authentication.py file, and this is where all of our kind of authentication is going to take place. So it makes sense to put it in here. And what we're going to do is we're going to define a function called generate hash. And it's going to take a string. And then we're just going to use what I had stored in main. What did I have stored in main? All of this lovely stuff. Let's take that. Okay. So we're going to encode our string. I'm just going to separate this out a little bit just so it's a bit clearer. So we're going to say our string is equal to our string.encode. Let's also get rid of this. My spelling's gone naff. Okay, there we go. Okay, we're in the zone. Cool. Can you tell I'm getting a little bit excited by the thought of hashing things? Okay, so string equals string.encode. And then what we're going to say is we're going to say hash equals our hashlib.sha56, and we're going to give it our string, okay, or our encoded string. Maybe I should call this encoded string. And then let's replace that with encoded string as well. Okay, lovely. So our hash is, we do that, and then we want to store our hash as a hexadecimal number. So what we're going to do is we're going to say hash equals hash.hexdigest, and then we're going to return the str of hash. So we're going to store that as a string, that hexadecimal number. Okay. I don't know what format it's in. I'm assuming it's a string because of the way it's presented in the console in the shell here when we tested it earlier. But just to be on the safe side, I'm going to string it just to make sure. Okay, lovely. So we should be able to run this now. So I wonder if I can import authentication. Maybe that's a bit much. Oh, I can. Great. Okay, so I should be able to say authentication dot generate hash, and I should be able to give it Bob, and it gives me nothing because I misspelt it. Brilliant. Okay, let's try that again. Authentication generate hash, and of course I didn't put Bob as a string. What is going on? Come on, come on. Okay, there we go. And you can see we got exactly the same hash as last time, okay? Well, you can't see it easily because it's a very long hexadecimal number, but we can see it starts with 81B63, and so does this one, 81B63. This is great because now I can say authentication.generate hash, and I can do password1, and that has given me this hash, and you can see this hash is completely different to our Bob hash. And now what I'm going to do is I'm going to take these and I'm going to save them in our users file. So I'm going to copy my hash for the username first. I'm going to go to my files into users.txt that I made yesterday. And we're going to store this in the format of username, comma, space, no space, space, username, password. Okay. And so I'm going to paste in Bob's hash there. I'm going to put a comma, and then I'm going to go down and I'm going to take the hash of the password, password1. Obviously, you could use a much better password. I would definitely recommend using a much better password. I don't think I copied that properly. Let's do that. Shift Control left selects the whole word, which is how I was able to select that whole thing in one go, which is pretty nifty. Okay, that looks better. So unfortunately, I'm so zoomed in that if I zoom out here, we can see they're both on one line there. That is very, very small. But they are both on one line. So we've got a username first, then our password. And what we'll do is we'll read this in from the file, and we'll hash whatever the user enters to us in our program. And if the hash, when we hash their username and hash their password, matches the hash that we've got stored on file, then we know they've entered the right one. Okay, so that's how kind of modern day apps deal with your password as well, like Facebook and whatnot. Google, they will be never storing your password actually on their servers. They'll be storing its hash because it's much safer. Cool. So let's go back into authentication. And what we're going to do is we are going to username equals input. So we want to create a username hash. So I'm going to say username hash. I'm just going to make a bit more space. I just feel a bit cramped, you know? Okay. I'm going to say username hash is equal to generate hash. And we're going to give it our username. And so whatever they type in, Bob, Steve, username 101, okay, we're going to give that to our generate hash function, and that is going to create us our username hash. And we're going to do the same with password. You're going to get absolutely sick of me saying the word hash, and I do apologize. I'm already sick of it. No doubt you are as well. We will be moving on from this word and never have to say it again. And you can see by wrapping it in this function, I've managed to use it a couple of times in the console in order to generate hashes for Bob and password. And now we're using it again when the user's inputting their information to check whether it's correct or not. So I'm just going to change this to password. Okay. And now what we're going to do is, instead of saying username equals Bob, we want to say if username hash is equal to we want to know whether it is in their file, right? We want to know whether it's stored in users.txt. So we want to maybe create a function. So def, what we're going to do, let's say valid user. Lack of a better word. Okay, so we're going to say define valid user, and in this function, what we want is we want the user hash and the password hash. I feel bad for putting user. I should put username. That's lazy. Come on. Okay, username hash and the password hash. And what we're going to do is we're going to read in the contents of our users.txt. Now, we're going to be needing to read files in a few places. So what I'm going to do is I'm actually going to create a function in our helper file that will allow us to read from a file. Okay. So I'm going to say sorry, I'm hopping around all over the place in these files. I hope you can keep up. Please feel free to pause me for just a moment of sanity. We're going to say def read file, and we are going to expect a file name when we use this function. And when we're reading our file, we're going to say with open. Using with is just amazing. It's the best way to read. You can do like file equals open, but with open means you don't have to specifically close it, and it's just a bit cleaner and nicer. So we're going to open our file name. We're going to open it in read mode, and it's going to be, we're going to refer to it as file. So we're going to call it file. And we're going to say, let's say data is equal to file.read. Okay, so we're going to read in the whole file. Oh, maybe not. Let's try that again. Okay, and then what we're going to do is we are going to return data. Okay, keep it nice and simple. So we're going to read the data from the file, and then we're going to return the data. So we can use this now, helper.read file. We can give it a file name, and we will get all the contents of that file given to us. Lovely. It's so nice when you work using functions like this, because you can just now, it just simplifies everything. The amount of code you're actually working on is much smaller. So now in our valid user function, we can simply say helper.read file, and we're going to give it the file name of users.txt. It's found that for me. Oh, users.users.txt. Let's try that again. Users.txt, and we are going to say users equals helper.readfile.txt. Now, what we are going to end up with is just one big string of all of our users, but what we actually want to do is chop that up so that we have our kind of individual users in an array. Okay, so what I'm going to do is I'm going to say user. Oh, do we need to actually? Don't think we do. You know. Oh, I think we can get away with not doing that. let's see if we can keep this simple. Okay, so now what we're going to do is we don't need to check the username and the password separately, right? We know that we are storing the username hash first, then a comma, and then the password hash. So all we have to do is we're going to say username hash, add a comma, add the password hash, and we're going to, I don't know, call this like credentials equals that, and then we're going to say if credentials being like, you know, your username and password, if credentials isn't, we're not going to check if it's equal to, we're going to say if it's in our users. Okay, so if there is a sequence in that string, our users string, it's just going to be one long string with all of the information in users. And at the moment, yeah, we just got one user, and I've also just got the little kind of reference for me that's username, comma, password. Okay, it's going to look and see whether that is in this file. And if it is, we're going to return true. So if credentials is in users, then we're going to return true. Else, going to return false. Okay, lovely. So we are getting the username, we're hashing it. We're getting the password, we're hashing it. And now we are going to say, we want to get rid of this. And we are going to say valid user is equal to, what did we call this? Valid, we called it valid user. Let's change the name of this function to is user valid. Okay, so this is like a question, like, is the user valid? And we'll get an answer. Yeah. And then we're going to say valid user equals is user valid. We're going to give it our username hash. We're going to make sure that we put these in the right order as well. So make sure that it's username hash first and then password hash, because that's what it's expecting. It's expecting those in that order. So we're going to give it our username hash and then our password hash. You'll notice that I'm not concatenating these in before I pass it into this function. I'm doing it up here. And that's simply because later, I might change how this works. Okay, so I don't want to, I just want to come to this function and change how the function actually operates. And so that's why I'm kind of concatenating it in here. I could have just concatenated them out here and passed it in as a string. In fact, I didn't really need this whole function, but it's nice to keep things separate. Actually. No, okay. I'm getting too carried away. So we're going to say if our valid user is true. Again, we don't have to put equals true. We can literally just say if valid user, but I like to do it just to help make it seem a bit good. Okay, and so you can see here that we have changed the functionality of how this function operates, but we've not actually touched the rest of the program. We've not had to go and change other things, so we can still keep this else all the same. We're still returning true here. We're still returning false here. Okay, and we've just updated the security of our program. So now, nowhere in my program does it say Bob or does it say password1, okay? Even in my users.txt, it does not say Bob, it does not say password1. And I could have any username, I could have hashed any username, I could have hashed any password and stored it here, and it wouldn't be obvious to someone. If someone stumbled along this on repl.it and were like, oh, I wonder what their username and password is, they wouldn't be able to take this value and reverse it, right? They wouldn't be able to take your blended meal and put it back together, reconstruct it. Okay, it's just a slurry, it's just a mess. And unless they were to blend up all the passwords until they found one that matched this exactly, they're not going to be able to know. And so we've made this app much more secure. And security is going to be a really big thing in this because we're going to be storing passwords, right? So we need to make sure that this is secure. Now, let's make sure this is still working. So let's run this, okay, and let's log in. Now remember, we've changed how this works. So no longer in the authenticate. So here where it says please enter your username, where's that? Here. Okay, so we're on line 21 at the moment. We're running that. So let's enter Steve. And let's enter password1. Invalid username or password. That's still working. That's good. Okay, let's try and log in again. Bob. Password1. We're in. Fantastic. That's great. So to reiterate, because I think it bears repeating, right? We are no longer storing any trace of what our username or our password was, apart from this video and last video where I explicitly tell you that it is Bob and that it is password1, okay? But if you were to come into this blind, and not blind, but if you were to come into this without any prior knowledge and look at this, we now know it's very secure. I hope I've driven that point home enough. Okay, we've improved our logon to be more secure, more than secure, I'd say. So we can say we have happily done that. I really need to have a log of things that we have done. It seems bad just deleting things straight from this to-do list, but that's okay. Make us feel getting that smaller to-do list. That's good. We've used all this code that can go. Okay, so I feel like we're on a roll here. So maybe we'll create a generate password function while we are kind of cooking with gas here. So we want to generate a password, and to do that, I kind of want to do it in a new file. But I don't know what that new file would contain other than that one function. So at the moment, I'm just going to do it in our main file, and I might decide to move our function later on. So we're going to say def generate, generate password. Okay, now, in order to generate our passwords, we need to know a few things. We need to know we need to know, what do we need to know? We basically need a bunch of true and falses, right? We need to know if it includes letters, does it include numbers, does it include symbols, does it include capital letters? So let's do contains letters. This is going to be long. Let's zoom out a little bit. Oh, hello, come on. Okay, so contains letters. We're going to have contains numbers, contains symbols, and contains capitals. Fantastic. So this is our generate password function, okay? And we want to know whether it contains letters, contains numbers, contains symbols, contains capitals. And I guess we also want to know its length. Okay, so we need to know how long our password is going to be. Now there is a pretty nifty function. Yeah, I said nifty. I said nifty. It is nifty. I'll zoom back in again so you can see the shell. So we can say ord of a character such as C, and it will give us a number. It will give us its ASCII number. So there is a character set called ASCII, and it essentially assigns not just every letter, but every number and every symbol and every control character in the English language. It assigns it a number, right? And what I mean by control character is like enter, backspace, tab, up, left, down, right, okay? All of those are control characters. And they are all assigned a number. And you can see here that the number that C is assigned is 99. So if I was to do ord A, we'd hopefully see 97. Yep, you can see that there. And similarly, if I was to do chr, CHR, and I was to put in 97, I would get A. Okay, so we can use ord and chur to take a number and convert it to a letter, or to take a letter and convert it to a number. And this is really helpful, right? Because if we know the range of where all the symbols live, or the letters live, then we can simply pick a number from that range, and then we can convert it to its character, right? So it will be quite easy to control what characters we have. So if Kura 97 is our lowercase a, then I think if we had 26, is it going to be 130, 123? No, too high. 22? Yes, 122. Quick maths. So we know that from 97 to 122 is the lowercase alphabet. I'm just going to make a note of these. 97 to 122 is lowercase. Okay. I believe uppercase starts at 65 because that's just kind of the cool information that my brain has stored in it. So I think if we do Kura 65, yeah, we've got an uppercase A. So we're going to have 65, and I believe that would go up to 96. No, we didn't. That doesn't sound right at all. 26, 80, 91. Being shown up here. Oh, 90. 90. 65 to 90, because 65 is included. Yeah, okay. So that is uppercase. And then we want our symbols and we want our numbers. Now, where do numbers live in ASCII? So let's do cur of, oh, no, don't want to type it there. I want to type it in the shell. We're going to do cur of, what am I going to do? 64? That's the at symbol, great. Let's do 52. Haha, great, lovely. So if we do 49, then that should be the number 1, lovely. And if I do cur 58, 57, I bet it's 57. Yeah, 57. Do cur 57, it's 9, and I'm assuming if we do cur 48, maybe that's 0. Lovely. So we can go 48 to 57 will be our numbers. And lastly, we want symbols. Now I'm going to have to look this up because I think they're dotted all over the place. So let's have a quick look at the ASCII table. I know it's everyone's favorite. Let's have a look here. Okay, lovely. So we've got a bunch of from 21. Oh no, that's hex decimal. From 33 to 47, we've got some symbols. Yeah, you can see they're kind of dotted around here. But that's okay. We will stick with 33 to 47 for the time being. We'll just use those symbols, and we could always add in other symbols later. So 33 to 47. Have I said that enough times? Great. 33 to 47. So let's pop that in, 33 to 47. And they are our symbols. Okay, fantastic. So now what we've got is a way of getting a character, right? If we wanted a lowercase character, we just pick a random number between 97 and 122, and then we use cur on that number. So we can say something. Have we got the random library in here? No. So, I thought I was putting this here. That'd be better. Let's import random. Okay, and we can say random.randint, and we are going to take a number between 97 to 122. Okay, and that will give us a random lowercase letter. So if I was to say print cur of, actually, no, we don't need to do so print. If I say cur of random.randint, take all of that and copy that, and let's pop that in the console here and just run that, paste it in. And I didn't import random into the console. Let's do that very quickly. Okay, so I should be able to now use that function, and I get an O, I, Q, H. So these are all lowercase letters. You can see this is working really nicely. And then if I was to change this range to, let's say, 33 to 47, the dot, full stop, dot, percentage, we've got another full stop, a single quote, a full stop. Okay, quite a limited range here, open bracket there. So we can see that this is working nicely. So we can use this idea in order to generate ourselves a password, okay? And now that we know the symbols, all we have to do is write some code that will allow us to decide if it contains letters, to use the letter range. If it contains numbers as well, we're going to use the letter range and the number range. If it doesn't contain symbols, we won't use the symbols range, but we will still use the letters range and the numbers range. And if it does contain capitals, then we'll use the capitals range as well as the numbers range and the letters range. Okay, so we are going to come back to this and program this in next time. Hopefully, I have kind of given you some food for thought there on how you might do this. And if you feel like you're on a roll and you want to carry on with this and see if you can create your own way of generating your custom password, by all means, go for it. But that is going to be what we focus on next time. I'm going to say, instead of create on my to-do list, I'm going to say we are going to we've already created it. I'm going to say we're going to update. I'm going to say make generate password function work. Okay, that's what our goal for next time is going to be. This time we've got this working. So let's just refresh our memory that in the console here. Oh, I've put in that, so it's not working. Where did I put it in main, didn't I? Silly me. Okay, this needs to go over here. There we go. Oh, let's choose my changes. Okay, so we have a nice safe way now to log in, and none of our details are stored in the actual program or in the file, and that is really cool. And now we're on a roll. We're ready to put in the main functions of the program and really get this working. I look forward to seeing you in the next one. Thank you for working with me today and working through this. I hope you have learned something, and I hope that you come along to the next one, where we will continue to develop this app and keep improving this until we have something that is super, super good and super efficient. And I look forward to seeing you then. Thank you for watching.